Greetings everyone. You are welcome back to JWow's Study World. Today our lesson will be on solving questions on how to find the number of sigma bonds and pi bonds in a molecule. So here you will find the number of sigma bonds and pi bonds in a molecule. So this topic is under valence bond theory. So we have find the number of sigma and pi bonds in the following molecules. So number one, we have chlorine molecule, Cl2, chlorine molecule. So solution. So for the first one, we have chlorine molecule. So if you want to find the number of sigma bonds or pi bonds, what you have to note is that you have to know how to draw the structure of the molecule. We have already learned how to draw these structures in our previous videos. How to draw the structures. When we were learning about the ionic and the covalent bonds. But now, you have to get those ideas to draw these structures. So for chlorine molecule, it has Cl2. So this one, it has two atoms of chlorine. So you have chlorine here, and then chlorine here. So they will form a bond like this. So from our previous videos, we learned that in a bond, the first bond that is formed is always a sigma bond. The first bond that is formed is always a sigma bond. So between this chlorine atom and this chlorine atom, the bond between them is a sigma bond because there is only one bond between them, and this is a sigma bond. So it means that chlorine molecule has one sigma bond and 0 pi bond. It has no pi bond. And now for H2O, which is water. So H2O, let's draw the structure of H2O. So you have O here, and you have H here, and H here. So this one too, we have only single bonds. So between this O and this H, we have only one bond. And the law states that the first bond is always a sigma bond. So this one, we have sigma bond, and this one too, we have sigma bond. And so it means that in water, we have two sigma bonds and 0 pi bond. We don't have any pi bond in water molecule. And now you have NH3, which is ammonia, NH3. So you have NH3 here. For this one too, we have only single bonds. So it means that each of them is a sigma bond, and the first one is a sigma bond. So since it's only one bond, so we have a sigma bond here, sigma bond here, sigma bond here. So we have three sigma bonds in NH3, which is ammonia. So we have 3 sigma bonds here and 0 pi bond. And now we have C2H6. So for C2H6, we have this one here. So you have C here, and you have two carbon atoms and 6 hydrogen atoms. So you have 1, 2. So we have 1, 2, 3, 4, 5, 6, and now we have this certificate. So now they are all stable. So let's check the number of sigma bonds and the number of pi bonds in this molecule. So this one, we have 2 carbon atoms and then 6 hydrogen atoms here. So 1, 2, 3, 4, 5, 6. So now let's check the number of sigma bonds and the number of pi bonds in this molecule. So since the first bond is always a sigma bond, so this is only one bond, so you have sigma bond here. Only one bond, so the first bond is only a sigma bond. Here too you have sigma bond, and here too we have sigma bond. Here too, between these two we have sigma bond. In this one too we have sigma bond. And now, for these two, the first bond is a sigma bond, and the rest of the bond become a pi bond. So the first bond is always a sigma bond, then the rest of them will be a pi bond. So we have only one here. So this will be a pi bond. So this will be a pi bond, and this will be a sigma bond. The first bond is a sigma bond, and the rest are pi bonds. So this is a sigma bond, then you have a pi bond here. So let's count the number of sigma bonds and pi bonds. So for sigma bond we have 1, 2, 3, 4, 5, 6, 7. So you have 7 sigma bonds in C2H6, and you have just one pi bond in C2H6. Now let's find for C2H2. C2H2. So for C2H2 we have two atoms of carbon and 2 atoms of hydrogen. So C2H2, so we have 8 here, 8 here, we have 8 here, we have 8 here, we have 3 bonds here. So now for this one, let's count the number of, let's show the number of sigma bonds and the pi bonds. So the first bond or single bonds are always sigma bonds. So this one, single bond, we have sigma bond. For this one too, we have sigma bond. For this one too, we have sigma bond. For this one too, we have sigma bond. Now for this one, you have 3 bonds. Note that the first bond is always a sigma bond. Then the rest are pi bonds. So for this one, the first bond is a sigma bond. Then the rest, you have a pi bond here and a pi bond here. So it means that you have 1, 2, 3, 4 sigma bonds and then 2 pi bonds in C2H2. So this is simple. This is a simple way of showing the pi bonds and the sigma bonds. You can also go by the by how to find it. You have the long way, like showing the water molecules. You have how the orbitals overlap to form the sigma bonds and the pi bonds. The sigma bonds are formed when the orbitals overlap on the same axis or head-on, and then the pi bonds overlap, and the pi bonds are formed when the orbitals overlap laterally or side by side or parallelly. Now, let's check the differences between the sigma bonds and the pi bonds. So let's find the differences between sigma bonds and pi bonds. So for sigma bonds, we are saying that it is axial or head-on overlap. So sigma bonds are formed when the orbitals overlap on the same axis or overlap head-on. And then pi bonds overlap, or it is formed when the orbitals overlap parallel or side by side. So you have parallel overlap in pi bonds. So for number 2, we are saying that sigma bonds are formed between SS orbitals or SP orbitals or PP orbitals. So when we have SS overlap, it forms as a sigma bond, or SP overlap, it forms a sigma bond, or PP overlap, it can also form a sigma bond. So let's show this one. We know that S orbitals can form only sigma bonds. So this one, so SS, you have 2 S orbitals. So you have S here, S is spherical, and you also have S here. So they can form a sigma bond by overlapping head-on. And then you also have SP. So you have 1 S here, you have 1 S here, and then you have 1 P also here. So this one to be overlap head-on, or they are on the same axis, so it makes it a sigma bond. You also have PP. So this one you have P here, and also you have P here. So this one to PP, they overlap head-on to give us, or they lie on the same axis to give us a sigma bond. Now for this one too, we also have PP, which will form a pi bond, not a sigma bond like this. but they are the same pp. So for that one too, we have pp like this. Here we have p here and then p here. This time they overlap laterally or side by side. They all have their axis. So here they all have their axis. They don't lie on the same axis. So this one is a pi bond formed between the pp. So pp can form either a sigma bond by overlapping head-on or a pi bond by overlapping side by side. We also have pd, also have dd. They are not. Now, for sigma bonds, the bond strength is stronger. The bond strength is stronger. So for sigma bond, the bond is very strong because the amount of overlap, or they are on the same axis. So it makes the bond very strong because the amount of overlap in the sigma bond is very strong. And now for pi bonds, the bond strength is weaker. So this will make the bond energy in sigma bond also strong. The bond energy is the energy required to break the bond. The bond energy is the energy required to break the bond. And since the bond strength is very strong, or since the bond is very strong, you require huge amount of energy to break these bonds. And this energy is called the bond energy. So the bond energy will become very strong in sigma bonds, and the bond energy will become very weak in pi bonds. Since the bond is already weak, you will need very minimum amount of energy to break these bonds. Now, for your assignments, you have to try this question. So this is your assignment. So question: find the number of sigma bonds and pi bonds in sulfuric acid. Find the number of sigma bonds and pi bonds in sulfuric acid, which has formula of H2SO4. H2SO4. So you have to draw the structure and then show the number of sigma bonds and pi bonds, and comment on the comment section your answer. Show your answer on the comment section. The number of sigma bonds and the number of pi bonds of sulfuric acid H2SO4. This is Jewel's Study World. You are welcome to join us anytime you want. Subscribe, like and comment this video or this channel to others. Make sure you share my videos. Bye bye.